Imagine you're commissioning a custom-built house. You sit down with your builder, slide a coffee across the table, and say, make it modern. I want lots of light. Give it a really open feel.
Right, the open concept.
Exactly. And you come back 3 weeks later, and the builder has constructed this absolutely stunning multi-story glass box. It's beautiful. But there are no doors.
Oh, boy.
Yeah, and no plumbing, and the floating stairs lead straight into a ceiling panel.
I mean, if you hand a contractor a mood board instead of a structural blueprint, they're going to interpret open feel in the most literal, structurally chaotic way possible.
Well, right.
They gave you exactly the vibe you asked for, just without any of the physics required to actually make it livable.
And that is, honestly, it's a perfect mirror image of what is happening right now in the world of software development. Welcome to the Deep Dive. We are thrilled to have you with us today as we tackle a really massive stack of sources.
It's a huge stack today.
It really is. We've got technical guides from Daily.dev and Red Hat. We have architectural teardowns from InfoQ and Excapit. Plus, there's this really fresh ArchitSpeed paper on something called Spec-Driven Development.
Yeah, that one is fascinating.
And we're also looking at a breakdown of API mocking tools like Postman and Stoplight, and even a pretty heavy critique by software architecture legend Martin Fowler.
It's a comprehensive stack for sure. And look across all of these documents, they really point to a singular, massive paradigm shift.
Which is what, exactly?
Well, the industry is rapidly moving away from the manual typing of code, and we're entering this era fully driven by AI coding agents. But, I mean, the growing pains are severe.
Yeah, so the mission for today's deep dive is to really shortcut your path for you listening to understanding this shift.
Yeah.
Whether you manage a tech team or you just rely on software to do your job, we're going to explore how the industry is moving from writing code to writing incredibly rigid specifications.
And we'll look at the underlying contracts, too.
Right, the APIs. How they're managed, faked, and versioned to actually survive this evolution. Okay, let's unpack this, starting with the death of what our sources call VibeCoding.
VibeCoding, it's really the perfect term for the chaos of the last couple of years.
It really paints a picture.
It does. With the explosion of large language models, developers just started treating AI like that overly eager contractor. They would prompt an AI loosely like, build me a sleek photo sharing app and just hope for the best.
And initially, the AI spits out code that looks entirely plausible. You run it, a button appears on the screen, and it feels like magic.
Plausible is the dangerous word there, though.
How so?
Because AI is fundamentally a prediction engine, right? It's fantastic at pattern matching the syntax of a coding language.
Yeah.
But it is entirely incapable of mind-reading your actual business constraints.
Like the boring stuff.
Exactly.
Yeah.
It doesn't know if you legally require that data to be stored locally versus in the cloud. It doesn't know your specific security constraints or how your system should handle a random database failure.
So it just fills in the blanks.
It guesses based on internet averages. And the result is code that looks super clean, but is, at its core, architecturally unsound.
Which brings us to the historical alternative. Because long before AI, the tech industry tried to solve this exact ambiguity with the infamous Product Requirements Document, the PRD.
Oh, the dreaded PRD.
Yeah, our Excapit source highlights that these were often these 40-page behemoths. They took months to write, and frankly, they were usually outdated before the engineering team even started their first 2-week sprint.
The fatal flaw of the traditional PRD was just that it was static. It was written in human language.
Which is messy.
Right. It's inherently fuzzy and open to interpretation. If a product manager writes, the system must handle high traffic gracefully.
What does gracefully even mean?
Exactly. A front-end developer might interpret gracefully as showing a nice little loading spinner, but a back-end engineer interprets it as, okay, I need to start dropping non-essential user requests to save the server. Human language just leaves way too much room for drift.
So if VibeCoding is handing over a mood board, and the old PRD was basically a novel that nobody bothered to read, Spec-Driven Development, or SDD, seems to be about providing the exact mathematical architectural schematic.
That's the core of it.
From the RSIF paper, it looks like SDD completely inverts the standard workflow. Instead of the code being the main event, the specification becomes the primary executable artifact. It is the absolute source of truth. And the actual code is just a secondary byproduct that gets generated mechanically.
That inversion is the key to all of this. In a pure SDD environment, the spec is machine-readable. It isn't a Word document. It's a highly structured file that defines every single input, output, error state, and data type mathematically.
Okay, I have to push back here, though.
Go for it.
If we are forcing developers and product managers to write massive, exhaustive specifications up front before writing a single line of code, doesn't that just mean we're dragging the industry back to the slow, clunky days of waterfall development? I mean, wasn't the whole reason Agile took over to stop planning everything up front?
That is the most common fear, and it's totally valid. But the crucial difference here is the speed of the feedback loop.
How fast are we talking?
Minutes. SDD isn't waterfall because you aren't waiting 6 months to see if your specification translates into a working product. STD uses a human-in-the-loop workflow. You start with your natural language requirements. You draft them, validate them, generate the code, and run continuous validation. It happens in near real time.
Wait. I assume the human was still manually typing out this hyper-complex specification file. You're saying the AI helps draft the blueprint, too.
Oh, absolutely. The cognitive load of writing a perfect machine-readable spec manually, it's just too high.
Too tedious.
Right. So instead, you give the AI your business requirements.
Yeah.
The AI translates that into the structured specification format. It does the mechanical work, like writing out the 50 lines of schema for a 404 not found error, or, defining that a username must be between 8 and 20 characters.
Okay, I see.
Then you, the human, just review that specification.
So you're editing the blueprint, not the building materials. And once you approve that blueprint, the AI generates the code directly from it.
Yes. And if the blueprint is perfect, the generated code will theoretically be perfect.
Okay, so if specifications are the new master blueprint, we really need to understand how rigid these blueprints are supposed to be. The ArcSIF source breaks this down into what it calls the specification spectrum.
Yeah, it's definitely not a one-size-fits-all approach.
Right. So at the most casual end of the spectrum, you have spec first. Here, you use the specification to generate the initial foundation of the code. But once that code is generated, the developers just jump into the code itself to make changes.
And the spec is essentially abandoned, or at least allowed to drift.
Which is great for quickly spinning up a prototype, sure. But for long-term maintenance, doesn't it defeat the purpose?
Yeah.
Because the blueprint no longer matches the building.
Exactly, which is why you move up to the middle tier, which they call spec-anchored.
Spec-anchored. How does that differ?
In a spec-anchored workflow, the specification is treated as a living document. It lives right alongside the code in the repository. If you need to change how an application behaves, you have to update both.
Sounds like double the work.
It is, but it's enforced by automated tests. Every time a developer tries to save their work, a script runs to verify that the code perfectly matches the specification. If they don't match, the system just rejects the change entirely.
Okay, which brings us to the extreme end of the spectrum. Spec all source. This is the sci-fi scenario where human beings are completely locked out of the code.
Literally locked out.
You only ever edit the specification. The system then automatically regenerates the entire code base based on your changes. And our sources mention several tools trying to pull this off right now.
Like Amazon Kiro?
Yeah, Amazon Kiro operates on a 3-step flow requirements to design to tasks. GitHub SpecKit forces a strict workflow using / command, going from specify to plan to tasks. And Tesla, this one blew my mind. Tesla literally drops warning comments at the top of the code file saying, generated from spec, do not edit.
Tesla's approach is highly ambitious because it fundamentally shifts the developer's medium. I mean, think about it. If you spot a bug in the application, your instinct as a developer is to open the code and patch it.
Right, muscle memory.
Exactly. In a spec-a-source model, you have to resist that muscle memory. You have to find the logical flaw in the specification, fix it there, and then wait for the system to regenerate the code.
Which leads to a really interesting and kind of concerning point raised in the InfoQ article. We're talking about tools like GitHub SpecKit, generating an enormous amount of markdown files, which are basically just formatted text documents for every single step of this workflow.
It's a lot of files.
Right. So if a developer wants to just change the color of a button or tweak a basic math calculation, and that requires them to review dozens of markdown files instead of just a few lines of code, haven't we just created a markdown monster? That sounds infinitely more tedious.
It's a massive risk, and it aligns perfectly with Martin Fowler's critique, which was mentioned in the stack. Fowler warns about the danger of spec theater.
Spec theater, like security theater at the airport, where it looks like you're doing a lot of rigorous work, but it's mostly performative.
That's the exact mechanism. Spec theater happens when maintaining the rigid formatting of the specification becomes this bureaucratic hurdle that actively slows down development.
So the tool becomes the obstacle.
Right. If your engineering team is spending 4 hours debating the exact phrasing of a markdown table for a feature that would take 5 minutes to just code by hand, the system has failed. The UI and UX of these SDD tools have to evolve.
Because nobody wants to read 50 raw text files.
Exactly. You can't expect that. The tools need to abstract that complexity, showing the developer a visual diff of the intent rather than the raw syntax of the file.
So how do we avoid falling into the trap of the markdown monster while still keeping the AI in check?
By drawing a hard line around where human oversight actually adds value, the human must remain in the loop for business logic.
Give me an example.
Okay, so humans make the nuanced judgment calls. For instance, if the payment gateway goes down, should the application fail open and let users access the content anyway, or fail closed and block them entirely?
That's definitely a business decision.
Right. The AI can't make that call. The AI, on the other hand, should handle the mechanical exhaust. You let the AI generate the 20 different ways a server might throw an error. A human shouldn't be reviewing every comma in the AI's error schemas. They should be reviewing the broader architectural intent.
That makes a lot of sense.
Yeah.
You verify the strategy, the AI handles the typing. Now here's where this entire blueprint concept unlocks a massive superpower.
The faking it part.
Yes. Because you have this machine-readable, hyper-detailed spec, you don't actually have to wait for the back-end engineering team or the AI to finish building the database to start working on the front end. You can just fake it.
This is the concept of API mocking. An API, or application programming interface, is really just the way two pieces of software talk to each other. Because your spec clearly defines exactly what questions the API can be asked and exactly what shape the answers will take, you can use specialized tools to instantly simulate that behavior.
It's basically like building a Hollywood movie set. The storefront looks completely real. The paint is fresh, the sign is up. So the actors, or in this case the front-end developers building the mobile app, can rehearse their scenes and wire up all their buttons.
Yeah, exactly.
They can do their jobs perfectly, even though if you open the front door of that set, there's absolutely nothing behind it.
The landscape of tools designed to build these digital movie sets is incredibly robust right now. The Testfully review in our stack breaks down several categories. You have open source options like Macoun and Mountebank.
And those run locally.
Yeah, those run locally on your own laptop and are great for quick, isolated testing. Then you have cloud-based tools like Maki or Biceptor.
And how exactly do tools like Biceptor work in practice?
So Biceptor intercepts the request your application makes. Let's say your mobile app asks the server for a list of users. Instead of routing to a real database, Biceptor catches that request and instantly returns a pre-programmed dummy JSON payload.
Just fake data.
Right. But it goes further than just returning fake data. You can configure it to simulate chaotic real-world conditions.
Like what?
You can tell Biceptor for the next 10 requests, add a 500 millisecond delay to simulate a bad cellular connection, or randomly drop the connection entirely.
Oh, wow. So you can test how the app breaks.
Exactly. This allows the front-end team to test how their loading screens and error messages behave without having to actually, unplug their office router.
The sources also dive deep into a comparison between two heavyweights in this space, Postman and Stoplight.
Yeah.
From the breakdown, Stoplight seems highly focused on the design phase. It's like a great drafting table for the blueprint.
Yeah, very design-centric.
But Postman covers the entire lifecycle. It handles the design, but also the testing, the mocking, the monitoring, and it acts as this massive collaboration hub. The critique in the sources is that using only a design-focused tool creates silos, where communication just breaks down the minute the spec is finished.
And that ongoing collaboration is vital because API mocking isn't just about developer convenience. It has immediate, tangible business impacts.
First being cost, I assume.
Huge cost savings.
Yeah.
If you want to run early-stage load testing, hitting the system with 1 million simulated users to see if the front end holds up, you don't need to spin up massive, expensive cloud databases if you're just hitting a lightweight mock server.
And I imagine there's a massive security benefit there, too. If you are faking the data, you aren't accidentally exposing real user passwords or credit card numbers during a test.
Precisely. By routing your pre-release testing environments to mock endpoints that only return synthetic, generated data, you completely eliminate the risk of a developer accidentally leaking personally identifiable information while they're just trying to debug a new feature.
Okay, so that covers standard web requests, what we call REST APIs. That's the classic model. The app asks the server for data, and the server hands it back. But modern enterprise systems are rarely that simple anymore.
What about event-driven architectures?
Right, event-driven architecture, or EDA, that flips the standard model on its head entirely. If a standard REST API is like calling a restaurant to make a reservation, a direct one-to-one conversation, EDA is more like subscribing to a newsletter.
So instead of asking for beta, the system just broadcasts it out to whoever is listening.
Yes, think of messaging systems like Kafka or RabbitMQ. They handle asynchronous broadcasting. So a billing service might broadcast a message saying payment processed.
And who does it send that to?
It doesn't know. It doesn't know who is listening. It just shouts it out. Then maybe an inventory service and an email notification service, who are both subscribed to that topic, hear the message and take their own actions independently. But if they are just shouting into the void, a standard REST blueprint isn't going to work. The sources from Capital One and intent-driven dev highlight that for these complex systems, we use the async API specification.
Yeah, that's standard.
It maps out the message structures, the pub subtopics, and the routing protocols. If you let an AI agent loose to build a complex event-driven system without an async API spec, it's going to build publishers and subscribers that are speaking entirely different languages.
The async API spec acts as the binding contract across all those asynchronous channels. It ensures that when the billing service shouts payment processed, it uses the exact vocabulary the inventory service is expecting to hear.
So mocking and drafting specs work perfectly in a vacuum before a product launches. But the moment real customers or other businesses start relying on that master blueprint in the real world, changing it becomes a massive liability.
It becomes the nightmare of evolution, API versioning. As Amazon's CTO Werner Vogels famously put it, APIs are forever.
APIs are forever. That is a heavy burden for an engineering team to carry.
It's a profound responsibility. Both the Red Hat and daily.dev guides refer to the Hippocratic Oath of APIs. First, do no harm.
I love that.
It's true, though. When you decide to upgrade your specification or add a new feature, you cannot break the applications of the people who are already consuming your data. If an external company built their entire app relying on your blueprint, pulling the rug out from under them destroys trust instantly.
So how do you actually evolve the system safely then?
The foundational rule is semantic versioning. You'll usually see it as a three-part number, like version 1.4.2. That represents major, minor, and patch changes.
Okay, break those down.
A patch the last number is just a bug fix behind the scenes. It's totally safe to roll out. A minor version introduces a new feature, but it is strictly backward compatible. It won't break anything that currently exists. But a major version...
A major version means you actually changed the structure of the blueprint. You moved a door, or you changed the format of the data in a way that will absolutely cause existing apps to crash.
Exactly. And when you are forced to make a major change, you have to run multiple versions of your system at the same time, routing users to the correct one. The mechanics of this routing vary. The most common is URI path versioning.
Which is what Twitter does, right?
Yeah. You'll literally see V1 or V2 right in the web address. It's highly visible and easy to route, but it can clutter up your code base over time.
The sources mention header versioning as an alternative to that. How does header versioning work?
Well, header versioning keeps the web address completely clean. Instead of putting the version in the URL, the client application passes a hidden piece of metadata, a custom header, along with their request, quietly asking the server for a specific version.
Oh, that's clever.
Companies like GitHub use this. It gives you very fine-grained control, but the downside is it's much harder for a developer to just casually test in a web browser because browsers don't easily let you attach custom headers to a simple click.
You could also use query parameters, right?
Right.
Like appending .version1 to the end of a link.
Yes, that's a middle ground. But the core challenge isn't really the routing mechanism, it's the lifecycle management.
Right.
How do you balance the desire to innovate against the sheer terror of breaking the system for everyone?
It seems like you need a really solid strategy for retiring the old stuff. Our sources point out some stark contrasts here. Salesforce is brought up as the gold standard. They release a new API 3 times a year. They're currently up to version 51, I think. But they still actively support versions going all the way back to version 30, which was released in 2014.
That is an unbelievable commitment to backward compatibility. It's expensive, but it builds incredible trust.
It really does. Conversely, the sources highlight Facebook and Twitter, both of which had infamous version 1.0 shutdowns. They surprised developers with aggressive timelines, basically forcing them to migrate to new specifications or face immediate cutoffs. It broke countless third-party applications and really alienated developers.
The lesson there is pretty clear. Never force a sudden disruption. If you have to deprecate an old version, you need to offer ample warning, provide step-by-step migration guides, and use feature flags.
Feature flags. Let's talk about those.
Feature flags are an incredibly powerful tool here. A feature flag is essentially a remote-controlled toggle switch inside your code.
Hmm.
It allows you to deploy the new version of your API into the live production environment, but keep it turned off for 99% of your users.
So it's there, but invisible.
Exactly. You can then flip the switch to turn it on for just internal testers or maybe a small beta group, monitor the traffic, and if anything goes wrong, you just flip the switch back off instantly.
Without having to roll back the entire code base.
Right, it takes the terror out of deploying.
Okay, so let's zoom out. We've got our rigid, machine-readable specs. We're faking them with mocks to unblock the front-end teams. We're protecting them with semantic versioning and feature flags so we don't break the internet when we upgrade. Managing all of this complexity for one single application is a headache.
A massive headache.
But scaling this across a massive enterprise with dozens of teams and hundreds of autonomous AI coding agents running around, that requires an entirely new level of governance.
It really demands an evolution in how we view the role of engineering leadership. And this brings us to the most advanced concept in our stack today, enterprise governance and what the SDD frameworks refer to as the Constitution.
Constitution. It sounds incredibly dramatic.
The drama is warranted when you consider the stakes. When you scale AI-driven development across an enterprise, you are no longer just managing code syntax, you are governing the behavioral constraints of the AI itself.
Which is terrifying.
It is. In enterprise tools like Spec-Kit, this constitution is an actual file, often saved as constitution.md inside a master memory bank folder. It serves as the bedrock document encoding your company's non-negotiable principles.
So what exactly is inside this constitution? Is it just coding standards like spaces versus tabs?
Oh, it goes way beyond formatting. The Constitution contains your mandatory legal compliance requirements, like GDPR data handling rules. It contains your specific authentication and security models.
So the AI knows the law, essentially.
Or at least your company's version of it. It defines your performance benchmarks, like stating no database query can take longer than 200 milliseconds. It even includes your front-end design system constraints. Every single time an AI agent spins up to draft a new feature or generate a module, it is forced to ingest and consult the Constitution first.
Wait, let me stop you there.
Sure.
If we are literally baking our company's legal compliance, our security posture, and our core architectural rules into a markdown document and feeding it to an AI, aren't we just blindly trusting a prediction engine to act as our lead lawyer and our chief architects combined? How can we possibly guarantee the AI actually followed the rules it read?
That is the most critical question of this entire shift, and the answer is you absolutely do not trust the AI.
Okay, good.
The Constitution is the rulebook, but continuous validation is the enforcement mechanism. The InfoQ article points out a profound shift in bottlenecks here.
What do you mean?
Historically, the bottleneck in software delivery was how fast humans could type out the code. AI has solved that. The new bottleneck is our absorption capacity, our ability to verify what the AI just generated. So the entire discipline of quality assurance, or QA, shifts. QA no longer tests the final code, QA tests the harness.
Tell me more about this harness.
The harness is a dense web of automated contract testing, static analysis, and runtime monitoring. The most advanced systems use things like eBPF proxies.
Let's break that down. What is an eBPF proxy doing?
Think of eBPF like a microscopic traffic cop that sits at the very core of the server's operating system, the kernel. It watches every single network packet that the AI-generated code tries to send in real time without slowing down the system.
So it's watching the live behavior.
Exactly. If the AI hallucinated and generated a piece of code that tries to send unencrypted user data to a third-party server violating the GDPR rules and the Constitution, the eBPF proxy catches the illegal traffic instantly and breaks the build.
It stops it cold.
Dead in its tracks.
And I imagine the magic here isn't just fixing the broken code, right?
Hmm.
If a bug makes it through, you don't just patch the specific line of code like you used to. You have to trace it back up to the source. You update the Constitution, or you add a new constraint to the specification so that the AI and any future AI agents never, ever make that exact mistake again.
That is the feedback loop perfected. And it fundamentally redefines what it means to be a software engineer in this new era. Your primary value is no longer tied to your ability to memorize coding syntax or debug a loop.
Because the AI does that.
Exactly. Your value is tied to your ability to clearly articulate intent, govern complex systems, and design the guardrails that keep the AI on track. You transition from being an individual contributor typing out functions to acting as a conductor, directing swarms of intelligent agents.
What a profound shift. Okay, let's take a breath and recap the journey we've been on today. We started by looking at how the wild west of vibe coding is collapsing, because AI needs strict architectural boundaries, not just mood boards.
Right.
We saw how the industry is replacing those vibes with spec-driven development, treating structured, machine-readable specifications as the ultimate source of truth, and letting the AI generate the code as a byproduct.
From there, we explored the specification spectrum, acknowledging the very real danger of the markdown monster and the need to keep humans focused on business logic rather than formatting text files.
We then looked at how to simulate these blueprints using mock APIs and tools like Bceptor and Postman, allowing parallel development and securing data.
Then we discussed event-driven architectures and async API, and how we protect all these live contracts using semantic versioning and feature flags so we don't break the internet with a single update.
And finally, we scaled it all up, governing this automated factory with AI constitutions and relentless continuous validation harnesses.
For everyone listening, whether you are a product manager, a systems architect, or a developer, the overarching takeaway from all these sources is clear. The mechanics of your day-to-day reality are changing. Your highest professional value is rapidly shifting from how to build the thing to clearly defining what the thing is supposed to do.
Which leaves us with one final, slightly mind-bending thought to take away.
Oh, I'm ready.
If the future of software is that code is entirely generated from specifications, and those specifications have to become so incredibly rigid, detailed, and mathematically structured that they essentially act as their own complex programming language, won't we eventually reach a point where writing the spec is simply too hard for a human being?
Wow.
Will we need an AI to write the specifications for our specifications? At what level of abstraction does human intent actually stop and the machine entirely take over?
It is the ultimate question of abstraction, and it strikes right at the core of human creativity in engineering. It is a frontier the industry will have to reckon with very, very soon.
Definitely something to mull over the next time you're staring at a blank text editor, trying to figure out where to start. Thank you for joining us on this deep dive. We hope it helped clarify the massive shifts happening under the hood of the tech industry. And remember, the next time you ask an AI to build you a house, make sure you explicitly specify that you like some doors. Catch you next time.